Need extra money for college? ISL Education Lending Scholarship Program provides $1,000 for college expenses. Registration is easy and no essay is required. Visit www.iowastudentloan.org/register to learn more. The scholarship is open to Iowa residents who are in high school and college students, as well as parents of those students. Register by November 30th for your chance at one of the 45 awards at www.iowastudentloan.org/register.
Come unwrap some holiday magic this season in Denver, where the lights are brighter and the shopping is grander. The shows are more spectacular, the trees taller, the festivities merrier. So come for your holiday traditions or make some new ones with your friends and family in the Mile High City, where the season feels a whole lot more wonderful. Discover great hotels and more things to do at milehighholidays.com.
This is SpaceTime, Series 23, Episode 75, for broadcast on the 22nd of July, 2020. Coming up on SpaceTime, astronomers discover a massive structure beyond the Laniakea galactic supercluster, a new hypothesis to try and explain the interstellar asteroid Oumuamua, and Gilmour Space successfully completes its latest hybrid rocket engine test firing. All that and more coming up on SpaceTime.
Welcome to Space Time with Stuart Gary.
Astronomers mapping the distribution of galaxies around the Milky Way have discovered a massive structure lying beyond the Laniakea galactic supercluster. A report in the Astrophysical Journal describes the newly identified structure, which has been named the South Pole Wall, as wrapping around the entire region like a massive arm. The densest part of this immense structure lies in the direction of Earth's south pole, hence the name, and appears to extend in a great arc of 200 degrees, that's more than a semicircle, reaching well into the northern sky. The concentration at the South Pole lies at a distance of 500 million light-years. Following the arm north, it folds inwards to within 300 million light-years of the Milky Way galaxy. Along the arm, galaxies are slowly moving towards the South Pole, and from there across the part of the sky obscured from Earth by the Milky Way towards the Shapley connection, which is the dominant structure in this part of the universe. One of the study's authors, Brent Tully from the University of Hawaii, says he wonders whether the South Pole Wall is much bigger than what can be seen. What Tully and colleagues have mapped so far stretches across the full domain of the region they've surveyed, and so this is expanding that work into unknown territory. The Milky Way galaxy, with its 100 billion or so stars, is part of the local group of galaxies, which includes Andromeda, the Large and Small Magellanic Cloud, and a few dozen others. This local group of galaxies, in turn, forms an outer suburb of the much larger Virgo cluster, which contains thousands of galaxies. And the Virgo cluster, in turn, is on the fringe of an even larger conglomeration of many rich clusters of galaxies, collectively known as the Great Attractor because of its immense gravitational pull. Then in 2014, Tully and colleagues mapped the Laniakea supercluster, a major galactic node, containing hundreds of thousands of galaxies, spanning more than 500 million light-years. The large-scale web-like structure of the universe consists of galaxies and galaxy clusters spanning along filaments and linking up at major nodes and surrounding the edges of massive voids. Laniakea is thought to be one of those nodes. This newly discovered South Pole Wall is as large as the Sloan Great Wall, one of the largest known structures in the universe, only it's much closer. It's never been identified before simply because it's a region of the sky that's not yet been fully surveyed, and where direct observations are hindered by foreground patches of galactic dust and clouds. In fact, the authors only noticed it because of its immense gravitational influence which has been imprinted on the velocities of sample galaxies. This is SpaceTime. Still to come, a new hypothesis to explain the interplanetary asteroid Oumuamua, and Gilmour Space successfully completes its latest hybrid rocket engine test firing. All that and more still to come on SpaceTime.
We can stop HIV, Iowa.
And it all starts with health equity.
Health equity means that everyone has a fair and just opportunity to be healthy.
To achieve this, we need to remove obstacles to good health.
Poverty and discrimination support an environment in which HIV thrives.
We must work together so that all Iowans have access to the resources they need to prevent, diagnose, and to treat HIV.
Visit stophiviowa.org.
Computer simulations suggest the mysterious interstellar asteroid Oumuamua probably formed its strange elongated cigar-like shape through gravitational tidal forces as it was cleaved off its parent body, almost like a slab of rock. Oumuamua, an Hawaiian expression meaning a messenger from afar arriving for the first time, was the first known interstellar object to visit our solar system. But its strange shape raised all sorts of questions about its origins, how it was formed, and where it came from. This alien asteroid is totally unlike anything anyone had ever seen in our solar system before. Its dry surface, unusually elongated shape, and puzzling motion even drove some to speculate that it might have been an alien spacecraft. The absence of radio emissions put that one back in the box where it came from fairly quickly, but mystery about the object has continued. Now, a report in the journal Nature Astronomy is providing scientists with their first comprehensive review of what it might be based on what we know. Astronomers use computer simulations to show how objects like Oumuamua could be formed under the influence of gravitational tidal forces like those felt by Earth's oceans. One of the study's authors, Douglas Lin from the University of California, Santa Cruz, says Oumuamua-like interstellar objects could be produced through extensive tidal fragmentation during close encounters by their parent bodies with their host stars, and then flung into interstellar space. Oumuamua was discovered already on its way out of the solar system on October the 19th, 2017, by the Pan-STARRS-1 Panoramic Survey Telescope and Rapid Response System in Hawaii. And it came as quite a surprise. Astronomers had expected the first interstellar object they detected would be more like an icy comet. After all, frozen worlds, comets and icy debris dominate the Kuiper Belt beyond the orbit of Neptune, and are thought to extend out into the Oort cloud, a sphere-like reservoir of comets orbiting the Sun beyond our solar system, which include a mixture of both objects created with our solar system and those from other star systems that have been caught up by the Sun's gravitational pull. These objects, thought to be rich in volatiles, are often flung out from their host systems through gravitational interactions and are then snagged by the Sun's gravity. And if they're bumped into orbits which take them to the inner solar system and around the Sun as long-duration comets, they become highly visible due to the sublimation of volatile compounds, which creates a comet's coma and tail when it's warmed by the Sun. That's all very contrary to Oumuamua's dry appearance, which was far more similar to a rocky asteroid and suggested a very different sort of evolutionary history. When a smaller body passes very close to a bigger one, tidal forces of the larger body can tear the smaller one apart. We saw this happen with the comet Shoemaker-Levy 9 when it came too close to Jupiter. And these tidal disruption processes can eject debris into interstellar space. And that's what's been suggested as the most likely origin for Oumuamua. So, to test the hypothesis, the authors used high-resolution computer simulations to model the structural dynamics of an object flying too close to a star. They found that if an object comes close enough to the star, beyond its Roche limit, the star can tear it into extremely elongated fragments which are then ejected into interstellar space. Thermal modelling showed that the surface of fragments resulting from this disruption of the initial body would melt at very short distances from the star, but then recondense and solidify at much greater distances, thereby forming a cohesive crust that would ensure the structural stability of the elongated shape. And of course, heat diffusion during the stellar tidal disruption process would consume large amounts of volatiles near the surface, explaining Oumuamua's surface colours, the absence of a visible coma, and its apparent dryness. However, water ices trapped deep inside would survive, only to be heated again later during Oumuamua's close encounter with the Sun. And that could have triggered some outgassing, which would account for the unusual non-gravitational accelerations detected during Oumuamua's outbound journey. It's a reasonable hypothesis, but it's not the only one, as Andrew Dunkley found out when he spoke with astronomer Professor Fred Watson.
A new theory about our exo-asteroid Oumuamua, affectionately known in the astronomical world as the space doogie.
Andrew, there's
at
only...
least by one person who's not an astronomer.
There's one person calls it that. Now, I wonder who that could be.
I have no idea.
I still go with the French breadstick analogy, which seems much more wholesome somehow. But of course, both of us are wrong. Yeah, the famous Oumuamua, the first messenger from afar, discovered getting on for 3 years ago. It was October the 19th, 2017. That Oumuamua was picked up and instantly recognized by astronomers as having come from outside the solar system because of its hyperbolic orbit, but also highly studied, in particular its light curve that demonstrated that this was an object that was not circular, that was kind of basically spinning end over end as it moved through the solar system, and that the light that we saw from it varied as the sunlight reflected from it increased and decreased because of the shape of it. So yeah, this elongated shape. And the thing that really set the cat among the pigeons as far as it being an alien spacecraft was concerned was the fact that it was experiencing what we in the trade called non-gravitational perturbations, which is a fancy way of saying something was pushing it off its orbit. And the expected cause for that, which would be outgassing, basically, which is what comets do. As the ices melt as they get near the sun, or the ices sublime as they get near the sun, that outgassing will change the orbit of something. So everybody looked very closely for signs of, either dust or gas coming off this thing, and none were found. It was simply a spot of light. So that led to the idea of alien spacecraft. And of course, the world's radio telescopes beamed in on it and nothing was heard. So there's probably only two people in the world who think it's an alien spacecraft. You might be one of them. I'm not the other. So theories have abounded. So... The theories for what it was or what it is basically usually involved an asteroid from another solar system, maybe one that has undergone a collision and hence it's been flung out of the solar system. Maybe what we were seeing here was the result of a collision of two planetesimals. These are the building blocks of planets in another solar system, because there's some evidence that the debris of that might be shard-like, might be this sort of shape. I think we confidently came to the conclusion that's probably what it was. But now there's another conclusion for us to come to, and I like this one very much because it gets right to to a fundamental level in astronomical, maybe the science of the way solar systems evolve. It goes right back to the beginning, because we know that star formation regions are often associated with what we call giant molecular clouds. These are giant clouds of molecular hydrogen. So hydrogen atoms join together to make H2, the hydrogen molecule, the most common molecule in the universe. It's everywhere. And these giant molecular clouds are very significant items within our galaxy. They're associated with star formation. So what has been proposed is that this object, Oumuamua, actually comes from one of those. The idea is that you've got molecular hydrogen, perhaps in the core of one of these giant molecular clouds, which is so cold that the hydrogen has solidified. And so you've got, as the lead author on this paper said, he described it as a frozen iceberg of molecular hydrogen. That's Darryl Seligman, who's actually, I think he might be at Yale, but he's on his way to the University of Chicago. He says, this explains every mysterious property about it. And if it's true, it's likely that the galaxy is full of similar objects. So what it explains...
Okay.
Go on.
So in terms of a normal asteroid, which is sort of dust and ice, this is a completely different animal.
Totally different. Nothing to do with planets or collisions of planets, but basically something that is spilled out of a giant molecular cloud, maybe by a collision between two of these things. The key thing that this theory offers to our understanding is that if it's outgassing molecular hydrogen as it passes near the sun, basically that's not going to show any visible sign. And in particular, there's no dust particles involved. There's actually no dust in this thing. Unlike a comet, which is basically a ball of ice with dust bound into it. This thing is just hydrogen. So what they have done is looked at the detail, the physics of how this might behave. There's no light, there's nothing to burn, doesn't reflect light, so you can't detect it. And you only get this stuff, molecular hydrogen ice, forming really almost at absolute zero. It's just a little bit above absolute zero. So these things are perhaps being formed in the cores, that's CORES, of giant molecular clouds, these places where stars are born. So it's an astonishing idea, but it fits all the bills. It fits the idea of the acceleration, fits the fact that we couldn't see anything outgassing. There's a nice explanation for the shape of it as well, because I
don't think it'll beat my theory, but let's go for it.
Author Darrell Seligman, he puts it beautifully. So what you've got, this thing's being irradiated as it passes through the solar system, and maybe it's gone through many solar systems. We don't know, or at least passed nearby to stars. So it's being irradiated with both the particles and the electromagnetic radiation from these stars. And what that does is just sort of, as he puts it, whittles away the surface. And what he describes, he says, imagine what happens to a bar of soap. It starts out as a fairly regular rectangle, but you use it up and it gets smaller and thinner over time. So he says Oumuamua has basically been wandering through space. This thing got smacked like a bug on a windshield, he says. And what he's suggesting is that, it encounters the solar system, the radiation from the sun actually helps to increase this slimming down process that gives you this very odd shape. Really neat theory. Problem is, that's as far as it goes. We can't really say any more because this thing's gone. However, we should be looking out for more. And a few commentators have mentioned that the telescope that will really bring these things home in terms of our discovery of them is the Vera C. Rubin Observatory, formerly the Large Synoptic Survey Telescope, scheduled to be online in a couple of years' time, hopefully. And that will, I think, net many interstellar objects, whether they're asteroids or icebergs from giant molecular clouds. Maybe we'll find out then.
Yeah, and you did say something that I was going to ask you about, but I want to go back to it. And that was, you said that these things come from the same clouds that form stars. Now, correct me if I'm wrong, but those clouds collapse under their own gravity, and that creates stars, which, is superheat. And yet these are at the opposite of the scale. Yeah. So it just seems sort of counterproductive.
No, it's a great point. So I guess what you're talking about is it depends on the density, on the amount of compression that there's been. So where the stars are forming, you've got really high densities of hydrogen and helium. That collapse under gravitation is what basically switches on star formation. But these molecular clouds are vast places. And when you think of things like the picture of the pillars of creation, the star formation in there is only happening right at the tips of those pillars of creation. There's an enormous amount of stuff around them, and these molecular clouds almost certainly have areas that are very, very cold indeed. That's what they're suggesting. So I think you can have both.
So these clouds produce both.
Yes, that's right.
Who knows what else they might be producing?
Exactly. What else is in there? But I do like the idea of hydrogen icebergs. That's one I've not heard of before, and I think is relatively new to the scientific community, at least the ones who are not concentrating on giant molecular clouds.
Very disappointed to learn that it's probably not remnants of the dog star. But anyway, that's the way it goes. But there was another one more recently, so they're probably thinking the same thing about that one.
That one is a comet, though. The other one's got all the signs of a comet, yeah. And actually very similar components to what comets in our own solar system have. So essentially there is still officially only one space doogie. There is indeed, that's right. Only one space breadstick as well.
That's Fred Watson, an astronomer with the Department of Science, speaking with Andrew Dunkley on our sister program, Space Nuts. And this is SpaceTime. I'm Stuart Gary. Still to come, Gilmour Space completes its latest hybrid rocket engine test firing. And later in the Science Report, an important study into the science behind the lofty and elite world of professional hot dog eating. All that and more still to come on SpaceTime. Gilmour Space Technologies has achieved one of the longest hybrid rocket engine test firings ever undertaken, a 110-second mission duration burn of one of its upper stage engines. The test burn, which more than doubled the duration of the previous test, is being seen as a significant milestone for the Gold Coast-based company, which is developing a new single-port hybrid propulsion rocket engine. Company CEO Adam Gilmour says the burn duration provided a full mission duty cycle as well as a throttle test. The controlled throttle down during the test demonstrates the engine's in-orbit ability to manoeuvre. The Queensland company is developing a new 3-stage orbital launch system using hybrid propulsion. Gilmour believes its hybrid rocket motor will be significantly cheaper, greener and safer to operate than traditional liquid or solid fueled propulsion systems. The company hopes to begin launching satellites into orbit from 2022. This is SpaceTime. And time now to take another brief look at some of the other stories making news in science this week with a science report. Scientists have uncovered a crucial component in the immune system which responds to the spike protein of SARS-CoV-2, the virus that causes COVID-19. Coronavirus particles have a corona or crown of proteins that resemble spikes, and it's this which enables the virus to attach to and enter cells in humans. The spike protein, therefore, is the target of most of the current COVID-19 vaccine trials. So scientists have been keen to investigate how the immune system, especially B and T cells, respond to the spike. The findings, reported in the journal Nature Medicine, show that people with strong neutralizing antibody activity had a robust B-cell response. But most surprisingly, it also showed that a particular subset of T cells called T follicular helper cells was a strong predictor of an effective immune response. A new study of 17 million people in the UK has confirmed that age, gender, ethnicity and underlying medical conditions are all risk factors affecting your risk of dying from COVID-19. A report in the journal Nature found men had a 1.59-fold greater risk of dying from COVID-19 than women, and age was also found to be a risk factor. People aged 80 or above had a 20-fold increased risk of dying compared to those aged 50 to 59. The study also found that the most deprived people in the cohort were some 1.8 times more likely to die from COVID-19 than the least deprived people. Black and Asian people were also found to be at a higher risk of death. However, contrary to prior speculation, this increased risk was only partially attributable to pre-existing clinical risk factors and deprivation. The International Union for the Conservation of Nature Red List has declared Australia's smooth handfish extinct, becoming the first marine fish alive in modern times to be declared gone forever. The bottom-dwelling fish was once so plentiful, it was one of the first species described by European explorers in Australia. But sadly, none have been seen for more than 100 years. Just as disturbing, fish throughout the handfish's habitat are being threatened by trawl fishing, pollution, and climate change. They said man would never break through the sound barrier. And it was until Chuck Yeager came along and did just that. And of course they said the 4-minute mile was impossible to breach. Until Roger Bannister came along and did just that. So, is there an absolute limit, a barrier that must be broken in the lofty and elite world of professional hot dog eating championships? Now, a new report in the journal Biology Letters says yes there is. Researchers analysed 39 years of data from the annual Nathan's Famous Hot Dog Eating Contest in the United States. Where else? They developed a computer model that suggests highly trained elite eaters cutting the mustard are theoretically capable of consuming 832 grams of hot dog matter in just 10 minutes, buns and all. And in case you're wondering, that's equivalent to 84 hot dogs. Imagine how many ground-up eyes, lips and buttholes that must include. By the way, the current world record holder is Joey Chestnut. He's managed to scoff down 74 hot dogs complete with buns in the 10 minutes allotted. That equates to around 21,000 calories. It's probably best not to think too much about the effects the next morning. But then again, elite hot dog eaters probably don't have normal, healthy gastrointestinal function. Meanwhile, us mere mortals probably couldn't get through more than about 10 hot dogs in 10 minutes. Now, How would you like your onions? And that's the show for now. SpaceTime is broadcast on Science Zone Radio by the National Science Foundation in Washington, D.C., and through both iHeartRadio and on TuneIn Radio. Or you can subscribe and download SpaceTime as a free podcast through Apple, Stitcher, Bytes.com, Pocket Casts, SoundCloud, Spotify, YouTube, Audio Boom, Podbeam, Android, Castbox, from spacetimewithstuartgary.com, or from your favorite download podcast provider. You can help support the show and the work we do by visiting the SpaceTime online shop and grabbing yourself a few goodies, or by becoming a SpaceTime patron, which gives you access to commercial-free double-episode versions of the show, as well as bonus audio content and other rewards. Just go to our Patreon page through spacetimewithstuartgary.com for all the details. If you want more SpaceTime, check out our blog, where you'll find all the stuff we couldn't fit in the show, as well as loads of images, news stories, videos, and things on the web I find interesting or amusing. Just go to spacetimewithstuartgary.tumblr.com. That's all one word and in lowercase, and that's Tumblr without the E. You can also follow us through @StuartGary on Twitter, @SpaceTime with Stuart Gary on Instagram, through our SpaceTime YouTube channel, and on Facebook, just go to www.facebook.com/spacetime with Stuart Gary. SpaceTime is brought to you in collaboration with Australian Sky and Telescope magazine, your window on the universe.
You've been listening to SpaceTime with Stuart Gary. This has been another quality podcast production from Bytes.com.